Hello everyone, I'm Daniel Savadin and it's my pleasure to be your instructor for this semester course, which is entitled New Breeding Techniques, Tools We Cannot Renounce for Sustainable Agriculture. This course is designed as part of an Erasmus Plus Key Action 220 Higher Education, and the name of the project is BioTeach. This project aims to bridge the gap between universities and industry and facilitate the transition from university to industry by bringing together biotechnology students and industry representatives through this course. Today we are going to delve into the fascinating world of new breeding techniques and explore their potential application in agriculture. By the end of this course, you should, and I hope you will, be able to acquire knowledge about modern plant breeding principles, including molecular, genomic, and phenomic, as well as biotechnological techniques in agriculture and crop transformation. Our goal in this class is for you to gain the skills necessary to select suitable target genes for genetic engineering and gene editing for crop improvement in order to improve the selection process of new resilient varieties using MBTs. We will evaluate the advantages as well as disadvantages of utilizing MBTs in agriculture, and we will acquire knowledge about the legislation on the use of crops obtained through the MBTs in Europe and in extra-European countries. By 2050, FAO organization estimates that the global population will reach 9 billion people and predicts that global food production will need to increase at least by 70% in order to cope with the resulting food security challenges. At the same time, climate changes negatively impact crop production as well as water and land availability for agriculture. Thus, sustainable yield increase, diminishing usage of chemicals and toxic compounds, enhancing crop resilience to biotic and or abiotic stresses, as well as improving nutritional and healthiness values represent the main concomitant targets to be pursued in agriculture in the shortest period of time. In this scenario, it will be very difficult, if not impossible, to succeed with conventional breeding, and the role of plant sciences and biotechnology becomes crucial for the future of humankind. The so-called new breeding techniques, or MBTs, offer the possibility of making genetic changes more precisely compared to the past by targeting specific sites in the genomes. These new tools are essential to maximize the potential of crops and to address the challenge of limited genetic diversity for important traits such as resistance to pests or efficient use of water and nitrogen through tolerance and improved nutritional content and taste. MBTs have the potential to reduce the cost and time of bringing new products to the market, since, compared with conventional breeding techniques, they can reduce the number of unwanted traits that might be co-transferred during the breeding process and that subsequently should be removed. The greatest potential advantages of MBTs are their relative ease, precision, speed, and low cost, allowing breeders to focus more on the local growing conditions and to react more quickly to the changing needs and wants of growers and consumers. Furthermore, unlike chemical or radiation-induced mutagenesis, often traditionally used as a basis for crop improvement, MBTs do not create multiple unknown unintended mutations throughout the genome. Thus, the resultant plant products are free from foreign genes and would not be distinguishable from the product generated by conventional breeding techniques. This calls into question what is meant by genetic modification and raises issues for the modernization of regulatory frameworks. By the 1990s, application of biotechnology methods in plant breeding resulted in new regulations and governance for the development and release of GMOs in specific countries. However, continuous advancements in the area of plant biotechnology have led to the widespread availability of MBTs that are not yet clearly defined in current GMO regulatory frameworks. Therefore, uncertainty concerning the regulatory status of products of MBTs remains a major obstacle to their commercialization in Europe. Specifically, for regulatory purposes, will the products of MBTs be classified under the current definitions of genetic modification? In a broad sense, MBTs can be categorized as those that employ target mutagenesis, in which transgenes are used in the early stages of breeding but the final plants are free of transgenes, or in those that employ DNA from foreign or class-compatible species and utilize one of the standard DNA transformation techniques. Recent advances in the field of agricultural biotechnology have left most governments unsure whether the products of MBTs should be regulated, with much of the debate being polarized. Those stakeholders who share the view that the new techniques should be exempt from GMO legislation generally argue that the end products are very similar, if not identical, to products generated using conventional techniques. Those with the opposite view contend that the new techniques are very similar to those used to create GMOs and thus should be regulated similarly. Stakeholders and seed companies have raised concerns that unnecessary regulation of products derived from MBTs will result in costly regulatory responsibilities, stifle innovation, and prevent the adoption of innovative breeding applications. The regulatory uncertainty of MBTs is a challenge for developers because registration costs will be low if the products from MBTs are to be classified as non-GMO, whereas the cost will be substantially higher if classified as GMO. The regulatory status of MBTs will affect the decision of the developers on whether to use these techniques only for the improvement of traits in products with very high value or for a large portfolio of crops applications. It is important, therefore, that governments avoid the creation of trade barriers due to incompatible and non-harmonious regulatory practices and policies. I encourage active participation, critical thinking, and respectful discussion. Learning is most effective when it is a collaborative effort. To get the most out of this class, stay engaged, attend lectures and laboratory work, complete assignments on time, and reach out for help when needed. Together, we can tackle this challenge. It's about more than just science. It's about ensuring a sustainable future for all. I want to express my gratitude to each of you for choosing to study this course, and I'm here to support your academic journey every single step of the way.